Okay, thank you. The next lesson in our sequences and series, the next mathcast, is called series. And when you see the word series and you think of the word series, what's the first thing that pops in your mind? Yep, I agree. The same as me. The Toronto Blue Jays in 1992 won what we call the World Series in baseball. And what that was they played a first game and they won. The second game they lost. The third game they won. The fourth game they lost. They won the fifth game and they won the sixth game. And to win the World Series, you have to win a total of 4 games. That idea can get extended to some of the things we've been talking about lately with sequences. We have this list of objects or this list of elements. And if we look at it in terms of a series, we don't want to just list the elements and find the terms. We want to add them up. We want to find the sum. We want to keep track of the number of, in this case, the number of victories. And if you hit 4 victories in the baseball World Series, you would win. So it's very similar to sequences. Sequences is just the list of games, win, loss, and so on. A series is the sum. A series is adding them all up to a total. So I said to my kids, what's another example, another thing that could represent series? And I asked them about the Netflix channel. And they said there's a show that used to be on, the kids might like, the little magic bus, or the school bus, I think it was called. And that's sort of the same idea of a TV series, in that you could have the episode 1, episode 2, episode 3, and so on, and they could add up to, a 15 episode series, or even I know it's called season 2. Season 1, season 2, season 3. So a season or a series could have 15 episodes in it. Another illustration that kind of represents series, I think, very well is money. And if you have a savings plan, suppose every month you are putting $100 into your bank account. Well, after 1 month, you'd have 100. After another month, you'd have another 100. And a third month, you'd have another 100. But what you're really curious about, you don't really care, well, you do. You do care about the monthly deposits, but you actually want to know about the sum. How much has all of that money added up to? And if we find the sum of a bunch of terms, that's the idea of a series. The same idea with buying a car. You make car payments. Every month you pay $500 for a car, and the next month you pay $500, and the next month you pay $500, and so on. You want this to total to the value of the car. So for us mathematically, a mathematical series is the implicated sum of a list of numbers that are generated according to some pattern or rule. Again, it can't be random. It's not a list of random numbers. We can't mathematically model randomness yet. So for now, we're going to keep it all consistent. These aren't just random numbers. There's a pattern. For example, this one's pretty easy to see. We have the numbers 1, 3, 5, 7, and 9. Before, we used to list them as 1, 3, 5, 7, 9. That's a sequence. Now, as soon as we put pluses in between, that turns it into a series. Now, the actual sum of this series is 25. It's important to realize that the actual sum is not classified as a series. The series is the implicated sum. It's just writing it out like this. So once we have some terms, suppose we want to find the sum of the series with the terms that were given. Now, if there's only a few terms, it's pretty easy for us to do. Okay, we would just add them up and see what we get. Now, clearly there has to be a more efficient way, and there is a model and there is a formula that will allow us to find these sums. To find the total, we're going to create what we call an arithmetic series. So for these four numbers, we add them all up and we get 430, just using our calculator. Now, there's an interesting pattern. If I have my sum of 100 up to 115, and if I reverse them, I take 115 to the beginning and reverse the numbers. If I add them, I would get s plus s, 1s plus 1s is 2s. I add up all the terms. And if I multiply by 4 and then divide by 2, I actually get 430. So what we're seeing here is just some mathematical tinkering, trying to figure out how can we write this model? How can we write an equation? How can we sort of capture this pattern algebraically so we can use it for a shortcut? And that's what we're talking about now. There's a quicker way to find these sums. We can find the mean of the first and last term. So the first term was 100 and the last term was 115. If we find the mean of those, I add the two together and divide by 2, and my mean is 107.5. And then I take my mean and multiply by the number of terms. So I take 107.5 and times it by 4, and I get my sum, my 430. It works. And it is amazing. But how does it work? Well, let me show you. So let's look at another example here just quickly. Suppose I want to find the sum of these numbers, 10 up to 30. I take the first number, or sorry, the last number, 30, the first number, 10. I find the mean, 30 plus 10 is 40, and 40 divided by 2 is 20. I take 20 and I times it by 5. 1, 2, 3, 4, 5. There's 5 terms there, so 20 times 5, and that gives me 100, which is the sum of those 5 terms. If I looked at this graphically, it may be easier to see. Here's my first number, 10. Here's 15, 20, 25, and 30. And these all add up to 100. Now, when I'm finding the mean, what I'm doing is I'm taking this extra chunk above the mean, that's 20, and I'm moving it over here below the mean to fill in that space. And then I take this extra chunk here above 20, and I'm filling it in over here to fill up that space. And what I'm left with are these 5 values at a total of 20. And 5 times 20 is that 100. And that's what we're going to do for our model. That's a more interesting pattern for us. So that's how the model is going to be written. So if we extend this approach to the general case, we can generate a formula that will allow us to find the sum of a series of any length. So for the sum of an arithmetic series, we are going to find the mean of the first and last term and multiply it by the number of terms. So to find the mean, I take the first term, the last term, divided by 2. That's how I'm finding the mean. And I'm multiplying by the number of terms. That's our formula. That's the idea of our formula. Now, if we look at this a little bit closer, the variable un, we actually have a formula for this. And this is a substitution that we do. So where that un is, I know I can replace this un with our previous term formula, which is this, which I'm going to do. So I'm going to make that substitution. Now I know this looks long, and this is looking a little clunky here, and this is okay. But just go back a bit. It's the first term plus the last term divided by 2. This is the first term plus my equation for the last term divided by 2 times n. Okay, this is how the formula is being built. Now from here, I can collect my like terms. And it ends up simplifying. I have my 2 like terms simplifying to this version. So this is the formula for the sum of an arithmetic series. Now, it's important to note that I want to show you where the formula came from, but you are not going to be asked to derive the formula. That's the formula. You'll be given the formula. I just wanted you to see where it came from. Okay? N is the number of terms, U1 is the first term, and D is the common difference. So let's try to use the formula here to help us out. So here are terms, 2 plus 4 plus 6 plus 8 plus 10. We know that's 30 already from before. I'm going to use my formula for the sum. N is 5, because I have 5 terms. 1, 2, 3, 4, 5. A is 2, that's my first term. And D is my common difference. D is what I'm adding every step here. So I'm going to plug them all in. And just quickly working through this, we see 2 times 2 is 4. 5 minus 1 is 4 times 2, which is 8. Do the brackets first for bed mass. 4 plus 8 is 12. And then have 5 divided by 2 times 12, which is 30, which is that total I was looking for. So the formula works, which is great. Now being asked to find the sum of this arithmetic sequence, I have the first term, the second term, the third term, and I have the last term. So the problem here is I don't know what n is. So I could plug in the -4 and plug in the -6, but n is a question mark. But that's okay. I know how to use the term formula to figure out n. So that we have to actually use 2 formulas in this question. So here's my term formula, which we've already studied. I can plug in, I know Tn is -94. A is my -4, my first term. D is my common difference, which was -6 in this case. I plug all the values into the term formula, and I see my only unknown is n. So I can operate on this, just the distributive property. Then I collect like terms, the -4 and the 6, and then I divide both sides by -6, and I get n equal to 16. So I now know that, okay, this -94, this was the 16th term. That was the 16th term. And if that's the last term, and that's the 16th term, then I know there are 16 terms in my sequence. So now, I just plug my values into my sum equation. And from here, it's just issue of bed mass. -2 times 4 is -8. 15 times -6 is -90. Brackets, they add to -98. And that's equal to -784, which is the sum. Okay. Determining the sum of a geometric sequence. Suppose we're given this one here. We start at 2, and we know it's geometric because I'm timesing by 2 every step of the way. I could just manually find the sum, just add it up and see the sum is 30. Again, we're going to tinker around this a little bit to try to figure out an algebraic method. So I'm going to classify the sum as adding these 4 terms up. And then what I'm going to do is multiply it by 2. And this is a step that you probably wouldn't think of. I'm going to times all the values by 2, and then I'm going to introduce a 0 here and slide everything over. And then, as it turns out, it's interesting. If I subtract my first list of S, all these things end up running to 0 except the very first pair and the last pair, which -2 and 32 equals 30. So similarly to an arithmetic sequence, these ideas can be extended to a general formula. So this is the general formula for the sum of a geometric series. And again, I just wanted you to see how we kind of tinker with those patterns to create the formulas. You're not going to be asked to generate the formula on your own. You're going to be given the formulas. And the key is just being able to understand and use the formulas. That's fine. So if it seems a little like we kind of just pulled it out of thin air, what we were doing there a little bit, well, it was a little bit when when people were initially generating those formulas. Don't worry about it. We just need to know how to use the formulas themselves. So just a quick question here. We're almost through. Determine the sum of this geometric series. 2 plus 4 plus 8 is 16. We know it's 30. U1 is 2. R is my common difference. Sorry, R is my common ratio. I'm multiplying by 2 as I go. And I know I have 4 terms. I plug them into the formula that's given to me now. 2 to the 4 minus 1 is 15 times 2 over 1, which is 30, which works. Okay, take a look at page 52 and page 54. There's a good example, number 18 on page 56, and then try number 6. Thank you.